Hello. In this example, we're going to look at the standard form versus general form for a quadratic function. Now, whenever we say quadratic function, what we really mean is a function that's written in the form f of x is equal to ax squared plus bx plus c. Now, this is just a quadratic function. You've seen this before. There is something called standard form for a quadratic function. This is the general form. The standard form is going to look like this. It's going to be a times x minus h squared plus k. Now, one thing I want you to notice here, this a and this a are the same thing. So this is this. Okay. Now, there's something called the Vertex Formula. And it specifically allows us to find h. H is negative b divided by 2a. That comes from this information here, negative b divided by 2a. And the k value is just whatever f of h is. In other words, what is f of negative b over 2a? So the biggest thing you need to remember is that h is equal to negative b over 2a. And actually, you already know this if you remember the quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, notice that if the discriminant is 0, all of that goes away. And what that leaves me with is negative b over 2a. So effectively, the vertex formula is the quadratic formula, just without the discriminant. Or in other words, when the discriminant is equal to 0. Let me erase all that here. Fantastic. Okay. Now, what I want to do before we go any further here, I want to start out with the general form, and I want to convert it into the vertex formula. Or, excuse me, the standard form. So this one is the standard. And I'm going to do that using completing the square. Now, notice that, or if you remember, f of x is y, right? So what I'm going to do here, I'm just going to replace f of x with y. So that gives me y equals ax squared plus bx plus c. Now, to complete the square, I first need the leading coefficient here to be a 1. And that's a problem because we have an a here. Now, what I'm going to do is I'm going to divide everything by a. And remember, this is not a problem because a cannot ever be 0. Because think about what happens if a is 0. That gives you f of x equals just bx plus c. And this right here would just be a linear function instead of a quadratic function. So that means that I can go ahead and divide by a and not have any problems. I'm also going to go ahead and subtract the c over a to the left-hand side. And that's going to make this y over a minus c over a is equal to x squared plus b over a x. Now then, if you remember, with completing the square, what we do is we take the number in front of x, which in this case is just b over a. And often I will tell you to just divide by 2, but remember this is a fraction, so instead of dividing by 2, think of this as multiplying by half. So what we're going to do is we're just going to multiply straight across and make this b over 2a. And once you have that answer, in this case b over 2a, we're going to square it. Now, because there's just one term here, everything just squares. There's one term in the numerator, there's one term in the denominator, there's just one big term. So square everything, and that's how you square it. So we get b squared divided by 4a squared. Fantastic. This is what we're going to add to both sides here. So that's going to give me y over a. Now I could do minus c over a plus b squared minus 4a b squared over 4a squared, but I'm just going to go ahead and add the b squared over 4a squared right now. And then put the minus c over a. You'll see why in a second. And then on the right hand side we have x squared plus b over a x plus b squared over 4a squared. Now look over here at the left hand side. What we have is b squared over 4a squared minus c over a. I'm not going to worry about the y over a right now because, well, y is y. We're going to solve for y. But I want the b squared over 4a squared minus c over a to be a single term. So what I'm going to do is I need to multiply both the numerator and denominator by 4a. So what this is going to give me is y over a plus b squared minus 4ac all over 4a squared. Now the right hand side, it will always factor, and it always factors the exact same way. It's always x something squared. This is guaranteed to be a perfect square trinomial. Now the something that goes in here is sometimes hard to see if you just look at this, but remember it's always the very first thing that you figured out up here, which is just b over 2a. So I'm going to add on b over 2a. Now I can subtract b squared minus 4ac over 4a squared to the left hand, or excuse me, to the right hand side, and then I can multiply by a. And whenever I subtract, I get y over a is equal to x plus b over 2a squared, and then the minus b squared minus 4ac all over 2a. And then I can multiply by a on both sides, and what that's going to do is that's going to give me y is equal to, I still have the a out front because this is a binomial squared. And then minus, if I take this, excuse me, that was wrong right here. This should have been 4a squared. So whenever I multiply this by a, the a times, the a divided by 4a squared is just 4a in the denominator. So this is just minus b squared minus 4ac all over 4a. Now notice that y is just f of x, so that's f of x is equal to a times, now I'm not going to leave it like this, I'm going to make this x minus something. And in this case, that something is going to be just negative b over 2a. And you can square it from that. And then minus all this, but I'm just going to say plus something. And that something is what k is. So I'm just going to make that negative b squared minus 4ac over 4a. Fantastic. What I want you to notice here is that this is standard form. The a is just a. The h here is just negative b over 2a, which is what we've just proven. And the k actually has a formula if you want to memorize it, but honestly I don't. So that's the negative b squared minus 4ac all over 4a. Okay, fantastic. So what we've just done is we've taken the general form and turned it into the standard form. Now, there are a couple of different things we want to remember. The first is that the domain for a polynomial function is always all real numbers. Now, the range, let me bring this down a little bit further here. The range for a quadratic, if we're graphing a quadratic, there are two possibilities. The first possibility is that it opens upward. And this only happens when a is greater than 0. In other words, the leading coefficient is positive. We also have a quadratic that can open downward. And that happens when a is less than 0. So there are two possibilities. Now, this bottom point or this top point, whichever one you want to look at it as, that's called a vertex. And the vertex is always in the form of h comma k. This is the x-coordinate of the vertex. This is the y-coordinate of the vertex, which is the entire reason that we find h and k, really. It's one of the most, they're one of the most important numbers for a quadratic. And so because of this, the range, if a is positive, it is from the y value going up. So it's going up for when a is positive. So the range would be the k value to infinity. And if a is less than 0, it would be from negative infinity to the k value. So effectively you can think of it as going downward. But we always write it down as, well, it helps if I use a parentheses there, doesn't it? Negative infinity to k. So this is what happens when a is greater than 0. This is what happens when a is less than 0. Fantastic. Okay. Now, remember that in general, a quadratic function will have x-intercepts if it crosses the x-axis, and it will always have a y-intercept. Okay, and notice that for the x-intercepts, y is 0. And for the y-intercept, x is 0. So what you can do is you can always find the x and y intercepts by setting x equal to 0 for the y-intercept and setting the y equal to 0 for the x-intercept and solving for the other. Now, one other thing to keep in mind is that for any parabola, there is also a vertical line that cuts the parabola in half. That is called the axis of symmetry. And the way that I've drawn it here is that the y-axis is the axis of symmetry, but every single parabola has an axis of symmetry, and I'm just going to call it an axis, and it's a vertical line, and so because it's a vertical line, its x equals a number, and that number is the x-coordinate of the vertex, and the way we've written it, h is the x-coordinate of the vertex. Alrighty. Fantastic. This is pretty much everything you need to know about quadratic functions, and I've done a whole bunch with just letters, I know. In the next few examples, we're going to be working with numbers. We're going to put a general form into the standard form. We're going to find the domain, we're going to find the range, we're going to find x-intercepts, y-intercepts, the vertex, and the axis of symmetry. We're going to do everything. And then, of course, we're going to graph it. Alrighty, well, have fun. I'll see you in the next video.